Uh, Welcome to our webinar. I'm Avi from Robusta. First, I'd like to say is thank you everyone for joining our webinar. And this webinar is part of a series about Kubernetes, so follow us to get more updates. I'd like to introduce Dragan Nastic, our speaker for today, who is a DevOps engineer at DemoStack. And he's here to talk about an interesting issue he had in his cluster with network traffic and how he solved it. Welcome.
Hi, Avi, and thanks for Robusta for inviting me. Okay, let's start. Splitting WebSockets and REST traffic with GKE Gateway. First, let me tell you something about me. I'm more than 1 year in DemoStack working as DevOps engineer. Basically responsible for everything that's infra-related, CI/CD, developer experience, monitoring, networking, so on. More than 10 years in IT, and the most important thing, I'm local Downstack Dart champion, at least for this quarter. Let's move with the WebSocket part. Today, I'll talk a little bit about DemoStack, about the problem that we faced, options that we consider, and the solutions that we choose. Let's start. DemoStack helps companies create, deliver, and analyze great demos. Our main products are tours. Companies can create visual guides for their clients on how to use and work with their application. We have Live, which allows companies to edit, update their live web applications, and present changed version to their prospects. And the main one is environment. Here we clone web applications and allows clients to do more advanced changes on their app. Clients does not need to have a dedicated demo environment managed by their IT teams. Clients also gain more stability compared to their production environment because they're the ones who do the changes and not developers. This is where the cloning story begins. Cloning is difficult. We need to support almost all front-end technologies in some way, and that's not easy. Some of the challenges that we have seen on our customer applications are race conditions, wrong DOM usage, browser security mechanisms, and third-party services, WebSockets, and many, many more. Let's talk more about WebSockets. With recent introduction of WebSockets, more and more customers started to use it. And of course, that had an impact on our product. The main problem is that WebSocket and REST traffic goes to the same endpoint, but they are very different types of requests. Among others, the main difference between WebSocket and the REST is that WebSocket is stateful protocol and use a single TCP connection for data exchange, and REST requires a new TCP connection for every request response, and it's stateless. That causes us performance issues, unstable platform, auto-scaling complexity. Sometimes we even had a denial of service because of heavy WebSocket connections. Since WebSocket has one connection and REST is basically every request, it's a new connection, it's very hard to determine how to do auto-scaling. WebSocket can take all your CPU, all your resources, memory, but REST traffic can hit the max connection limit. It becomes a very annoying issue that we had to solve somehow. How to split WebSocket and REST traffic? Well, someone will say, that's easy. Everyone knows that you can split traffic based on the path. Well, that is true if your product supports it. But as I said before, cloning is difficult. we had to find a way to split the traffic that goes to the same service on the same path. Find something unique for a WebSocket that can be used to split the traffic before it reaches our service. We started to investigate. Well, the WebSocket protocol has two parts, handshake and data transfer. In handshake part, client requests the WebSocket connection by using the specific headers to set up a handshake. Those headers are boundary and connection headers. And this is exactly what we're looking for. With this information, we can use header-based routing and split WebSocket and REST traffic. Options that we consider. Now, we know how to split the traffic, but let's see what is the best option for us. GKE Ingress, well, it does not support header-based routing. Istio, it's a service mesh mainly. It's much more than just the Ingress feature with the header-based routing. And it's a bit complicated to set it up in our case. If you use Terraform handling to manage the load balancer, it's possible, but it puts another layer of complexity to our infrastructure. So we have decided to go with GKE Gateway. Even that has been recently released as general available in November last year, I think. It has everything that we need for this use case. It's a GKE implementation of Kubernetes Gateway. It involves and improves Ingress resources in many ways. It's role-oriented. Platform administrators can create, define policies to allow different teams to consume the shared network infrastructure. Gateway does not have to be provisioned in the same namespace as your service, but like Ingress does require that. And the most important, it has a built-in functionality for header-based routing. This is how our architecture look like. So here we have two users. One is REST, one is a WebSocket that tries to make requests to our endpoint, which is load balancer. Load balancer sends those requests to the gateway controller. Gateway control based on the header that's in WebSocket decide on which deployment, on which pod service to send specific traffic. So for the WebSocket, we have different deployment is the same service, just different deployment, different pod. Go to one deployment and REST traffic goes to another deployment. This is how configuration for HTTP route looks like. So it matches headers with the name upgrade and the value WebSocket. Challenges that we had during this implementation, it's lack of documentation. Not all Kubernetes Gateway features supported because GKE Gateway, it's implementation of Kubernetes Gateway, so they really don't support everything that Kubernetes Gateway has. Specific GKE version, it's required so you can deploy all those custom resources. And they have also load balancer limitation. If load balancer does not support some feature that you can specify in Kubernetes Gateway, it will not be supported by GKE Gateway as well. But we have some early results. We have less performance issues because we split the WebSocket traffic, of course. We have better observability, better visibility of traffic. we can determine if WebSocket or REST traffic are making issues and where, which requests, so on. We have better resource allocation because we separated servers into two deployments. Now resources are more allocatable, and we can configure now backend configuration for load balancer, like backend timeout, for example, for REST traffic. It doesn't need to be like 30 minutes, 10 minutes, like it should be on WebSocket. It can be 30 seconds, but again, on WebSocket, it can be much, much higher. Next steps that we plan to do, it's different cluster configuration down the road. We need to set up our cluster now differently to meet our needs, actually client needs. We can improve the auto-scaling policy with the traffic-based auto-scaling, which is also supported by GKE Gateway. And we can do more resource utilization in better way with the node pools, specific request limits for WebSockets and for REST traffic. I think that I covered the most of it, and thank you.
Thank you so much for talking. That was fantastic. Like me personally, what I found like very interesting was the capabilities that you can do with that. Like for developers, I personally a few times had to completely like upgrade or redo the entire backend, and now you have a whole way of being able to set specific headers to go to specific versions of the backend. I don't have to spend forever making sure everything's backward compatible. I have the old backend, I have the new backend there, and based off of the header, I can redirect the traffic. It's great. I'm excited. I want to play with it already.
Yeah, it's really great. You can do blue-green deployment, canary deployments with it. It's much, much flexible and advanced.
Does anyone have any questions? I have questions if no one has questions. I wanted to ask, is it built into GKE? Like when you install the new version of GKE, or do you have to enable it or do some changes just for your cluster to be compatible with GKE Gateway?
It starts from version 1.24, and you need to enable it. I'm not completely sure, but I think it will be enabled by default in 126 or something like that, or 127. And you can just start to use it, basically.
Are there
but
like
even if you need...
No, continue, sorry.
But even if you need to enable it, it's very easy to do.
Are there additional costs involved with it? Like, I know that Azure and Amazon have something similar, and they have additional costs that they add on to it.
No, there's no additional cost. The costs are only the load balancer costs that you provision. And GKE Gateway started with support for only 2 load balancer, but now it added almost all of them. There's new next generation HTTP layer 7 load balancer that is supported by GKE Gateway as well. So only the load balancer costs.
Do you think you're gonna keep using Ingress also in addition to this, or are you gonna only use GKE Gateway now too? Because you can have specific APIs go to the gateway, specific ones go to Ingress, right?
Yeah, but you can use it. You can use Ingress. It's pretty simple. It's straightforward. If you have a need for it, don't need anything complicated, anything advanced, then just go with the Ingress. But the gateway, It's very good feature. It's role oriented because then you can be, if you're a platform administrator, you can be in control who actually expose the services that are running on your Kubernetes cluster and be more secure in that way. With Ingress, you cannot do it, but that's where it depends on the needs, actually, I would say. But yes, we will keep use Ingress and the gateway as well.
Is there any downtime when you're setting up the gateway? Like, is there like a minute or two where the traffic's still being routed how it used to be?
When you set up the gateway and you already have an ingress, there's no downtime because you're doing in parallel. You set up the gateway next to the ingress, and you're just doing a DNS switch, and just leave the ingress because of DNS propagation. It can take 24 hours, but it's usually much faster. So there's no downtime, which is pretty cool. You can do it in production directly.
You have it running in production now?
Yes. Yeah.
Cool. If there are no more questions, thank you. It was fantastic. Thank you so much for giving this talk. And thank you to everyone who participated, everyone that's watching. Feel free to follow us for more Kubernetes talks.
Thank you very much.